Good morning and welcome to another episode of Stuart's Classic Bikes and Cars. Well, today I'm at home. I'm just going through my timings for the port openings and closings for the Kawasaki HD3. Now, as you can see on here on the port timings, the exhaust port opens at 97 degrees after top dead centre. The cat is now trying to steal a limelight. The exhaust closes 92 degrees before top dead centre. The three transfer ports open 120 degrees after top dead centre. The transfers close 118 degrees before top dead centre. Right, the rotary intake valve opens 43 degrees before top dead centre of the piston, and it closes 110 degrees after top dead centre. Well, at the moment I'm not going to alter the intake disc, and I won't alter the position of the transfer ports opening and closing. I will alter the exhaust port. Just let me show you what I'm going to do. Right, so you can just imagine that I've cut the cylinder and laid it flat. That's the exhaust port, that's the right hand transfer port, that's the rear transfer port, and that's the left hand transfer port. There's one exhaust port and three transfer ports. So what I'm going to do, the exhaust port at the moment is 35.5 from the top deck where the cylinder head bolts onto to the top of the exhaust port. What I'm going to do, I'm going to mark it out and carefully grind this top away to make this exhaust port 2.3 millimeters higher. So I'm going to higher the exhaust port by 2.3 millimeters. Now, in between the right hand transfer port and the rear and the left hand transfer port, there's a gap between the ports of about 15 millimeters. What I'm going to do, I'm going to mark out and carefully grind in two boost ports. Now these boost ports will be 7 millimeters wide and 3 millimeters deep, and I'll grind them in with a rotary burr. They'll go from the bottom of the barrel through the spacer ring at the bottom of the barrel and go up and open at 45 millimeters from the top deck. All these three transfer ports at the moment are opening 45 mil from the top deck. So I'm going to put in two more boost ports, 7x3, and they will also open at 45 millimeters from the top deck. So that's the first bit of tuning I'm going to do. What I'm going to do, I'm going to alter this, I'm going to grind these in, and then I'm going to put my timing disc on and put a light in the exhaust port on the transfer ports, and I'm just going to check the degrees again of the transfer ports, the exhaust port opening and closing after I raise it by 2.3 millimeters. Now, if you can just bear with me with one more thing to address, and that is the squish band on the piston top clearance. Just let me show you what the problem is here. Just let me whack, old school you see, no whiteboard, still using chalk and a blackboard. This was my job when I was at school. When the teacher was fed up with me messing about in the class, used to make me clean the blackboards, which I used to do regularly. I didn't like school very much. Right, there we go. So if we can just imagine, this is the, I'm just going to draw on here the cylinder. Right, just imagine just imagine this was the cylinder. What we're going to do, that's the centre. This is the piston. Right, ladies and gentlemen, just imagine that this is the cylinder bore here, and that's the piston in the bore. At the moment, when that piston is at top dead centre, when the piston's at top dead centre, it's stuck proud of the top deck by 0.1 mm. That's 0.1 mm, which is 4 thou. So when that's at top dead centre like that, it's stuck, it's a 0.1 millimetre stuck out, that's all, above the deck. But the outside of the piston here is 4 millimetre lower. So if you can see what the problem is, the piston is 0.1 millimetre proud in the middle, but at the side and the piston is 4 millimetre lower than the top deck. The piston is a dome shape, which is okay, that's correct. But the problem I've got, just let me do you another little drawing. Just clean my board again. That's roughly the shape of the cylinder head. That there's a spark plug. This is what goes onto the top of the barrel here. The problem is that when the piston comes up, when the piston comes up to top dead centre, and this is the cylinder head here, this gap here, which we call the squish, that's the squish clearance there. Now we're aiming for 0.8 mm squish clearance. So when I get all this built up and everything finished, when that piston's at top dead centre, I want this measurement here to be 0.8 millimetre squish clearance. The problem is that when this top dead centre, the piston isn't there. It's a lot lower. So this squish clearance here is approximately 3 to 4 millimetre. So this clearance here at the moment is way too big, because this piston is sat too low, or the barrel needs to come down to let this head come down nearer the piston. But if I lower the barrel down, it's going to alter my ports and my port timings. I don't want to do that. So what I'm going to do, I'm going to machine a piece off the barrel, off the top of the head, sorry, a little bit off the head and a little bit off the top of the barrel. So I get this clearance to 0.8 millimetre. This will make a big difference for the tuning. I need to keep that ideally at 0.8, but anywhere from 0.8 to 1 millimetre I'd be happy with. So that's, once I get my port timing sorted out on the previous blackboard, this is my next thing I'm going to address. The squish clearance between the piston and the cylinder head. This is the squish here. This is the squish clearance there. The other thing I need to do is work out the volume in here. This volume of air in there is the compression ratio. So apart from the squish clearance, I also need to work out the compression ratio. So that's what I'm doing today, folks. So stay with me, keep watching, and I hope you find it interesting. It's only a little bit basic. I'm just trying to explain to you in layman's terms what I'm trying to do. Thank you. See you all tomorrow. Bye-bye.